I saw this video a little bit ago, and I'm going to let you know I have gotten a little heated up by this guy before in the past. I'm going to not get heated up. Okay. You should always listen to everyone's argument as it is. And so I have to, because if your code looks like this, you're a good programmer. I just want you to know that generally speaking, the best programmers I have ever seen write really shitty code. One of the best programmers I ever saw in my lifetime, his code was by far the most atrocious code I've ever read. I actually hated it. I hated working with him. But man, could the guy get stuff done. Okay? So I'm just saying, it depends on your measurement. Depends on your measurement. All right? And I worked with someone that always wrote really nice code, and I hated working with them because everything was an argument. Oh, that variable name is slightly too short. You know what? Like the thing that I hate is when you work with some people that are these like good code Andes. It's like you do a promise and you have res and reg. Right? Like, dude, do you really care in JavaScript that you're using res and res versus resolve and reject? It's just like, dude, you're killing me. You're killing me. Why are you making this a hill you want to die on? Like, out of all hills to die on, why is this one? Oh, we got to use reject and resolve or else it's completely ununderstandable. It's like, it's not that it's not like that misunderstandable. Oh, my goodness. It just kills me. How many times we discussed this, dude? It's just too much. It's just too much. It kills me. It kills me, honestly. So I'm curious what this means, but here we go. So everybody, you ready?
We all say it. That code is bad. This code is terrible. But what does it mean? And what should we do about it? That's our topic for today. Hi, I'm Dave Farley of Continuous Delivery and welcome to my channel. If you haven't been here before, please do hit subscribe, and if you enjoy the content today, hit like as well. Bad code is probably a bad name for bad code, but at least colloquially, if not technically, we all know what we mean when we say it. That is...
But this picture of this hacker just made me so upset.
Code, but at least colloquially, if not technically...
I hate the fact that this guy's like a hacker guy and he keeps looking at his keyboard.
We all know what we mean when we say
like that. Dude, why are you looking at your keyboard? What is this? What are you doing? How are you typing without looking at your keyboard for an extended period of time, then typing again by looking at it? What stock footage is this? Why am I triggered by the most trivial things? Oh, I'm a good programmer. I can just tell right away. When you're triggered by the most trivial things, it means you're a good programmer, by the way, just so you know. Have you done the government Rust thing yet? No, I haven't. Low-level learning, would you like to come on next for that? Low-level learning, would you like to come on and talk to me about government and Rust thing? Yeah, let's do it. Okay, let me get through this video, which, judging by the length, it will be 1 hour from now. I'm not going to rage, dude. I can't help it. I literally cannot help it. I lose... I actually turn into Goodwill Hunting, and I'm like, I'm losing my fucking marbles, right? Dude, I cannot help this. Oh my goodness.
That is not how I would have done it. Or if it's our code that's bad, it's not how I'd do it now with the benefit of hindsight. Bad code is code that is difficult or at least unpleasant to work on.
I don't know if I agree with that fundamental premise. The reason why I say I don't agree with that fundamental premise right off the rip is that code that can be unpleasant to work on can also be marred by the fact that it is complicated by its very nature. And what I mean by that is like a very classic topic of difficulty at Netflix is on the television app, there is no such thing as focus. Focus is a made-up term on the web that does not exist on TVs. And so we had to create our own focus ring and our own focus that goes all around. Now, obviously, this is a very complicated topic, and I've had to work on focus code multiple times. Is it easy? No, it's not easy. It's really not easy. And so whenever you do these kind of things that say like, oh, this code, since it's hard to work on, therefore it's bad, it's like, is it? Or is the topic itself really, really difficult? And the reality is that the topic itself can just simply be really difficult. And that's that. Do you mean like CSS focus, like when you press tab? Yeah, like that's one way. But like, just think about when you use Amazon or when you use Netflix or when you use any of these things on a TV, you got to remember that, you know how there's like a ring that shows you what video you have highlighted? This is not some sort of platform provided thing like tab and input boxes on the web. Focus, that focus and focus order is a provided to you thing. Whereas on TV, it does not exist.
This episode, I want to explore what bad code really is, what's a sensible practical definition for good code, and what it takes to build good code and avoid traps in.
How is she just typing? Yo, how is this person typing? How are they typing? Neuralink? This is crazy. Is that Neuralink, man? This is crazy. This is crazy. Anywho, is this what AI generated stuff looks like? Because this can't be a real office. This has to be all AI generated at this point. They're watching a tutorial. Is that it? Watching a stream? Okay.
To build good code
programming
and
in
avoid
Microsoft
traps in
something?
bad code based on some real world examples.
I actually do like the fact that he's attempting to define what bad code is. I'm very excited to see what bad code is because that is very important in my head. Because if you can't give a concrete definition other than code I don't like, then I don't think you know anything. Like, honestly, I don't think you know anything.
Fundamentally, bad code is defined, I think, by two things. Either it doesn't do what it should, or even if it does do what it should, it's too hard to change it when we need.
I disagree with the second point. I think it just really depends on the problem and the amount of, again, go back to focus. Imagine you had to change focus for an entire platform like Amazon Prime. You think that would be easy change? Would that be a fun change? How about there was a time at Netflix that we used to do this thing where there's all these lists of movies right here. And how we represented this list of movie was a tree. Technically, it was a graph, but for simplicity, I'll just show it as a tree. It started off as a Lolamo, right? And it was a Lolamo, and then inside of it was like a big UUID. And then inside of that would be a list, and then that would have like, say, numbers 0 through something, which actually this 0 through something was another UUID, right? So it'd be Lolamo. And then technically this one would be like 0 would point to a list, 1 would point to a list, but it's actually by ID. So I'm just kind of like abbreviating the structure. So this is by ID, and then this would have a list of videos. So this would be, video 1 that would have like, say, a title. It would have like a description. It would have like maybe a rating, blah, 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 blah. And this would go on for quite some time. Okay, so you get the idea. Now, here's a problem. When you organize your data structure like this, when two lists point to the same movie, they are actually pointing to the same object. So when I try to put some sort of badging right here that says, you would like this video because you like tough men doing tough jobs, right? And say it's live free, die hard. And then in the next video, it's Bruce Willis action movies. I couldn't change that description for why you liked it from tough men doing tough jobs. Instead, it should be because you like Bruce Willis. I couldn't do that because of the shape of our data structure. So I had to change our data structure to include one more item inside the list. So it'd go instead of list 0, like say list. So this list would represent one of the rows. 0 would be the 0th title. I couldn't just simply go 0 title. Instead, I'd go 0.video.title and 0. Like say reason. I had to add in an entire like node into our graph to be able to add in these like badging and things. And so to change the data structure of the entire code was very, very difficult. Does that mean that the code itself was bad, or was the problem hard? People are saying, yeah, I think you guys are losers. I didn't know that was a term. Yeah, Lolamo's a loser. Neither can be true. Both could be true, yeah. You should have used abstraction. More abstraction. What is up with you and Pirate Software drawing boxes? Boxes are how you describe things. I know this may sound shocking, but if you've ever been to any schooling ever for all time of life, you would draw a box. Don't write bad code. Write badass code. Thank you.
Need to change it. I'd argue that that's it. Everything else is secondary to those two things.
So quick question. If you've never worked with C++ and you got thrown into a C++ code base, is the code bad, or do you have skill issues? If you've never worked with JavaScript and you got thrown into a JavaScript code base, if you got thrown into a Python code base, if you got thrown into any code base that you're not familiar with, and it's hard to change, are you bad? Are you filled with skill issues, or is the code bad? The proper answer is you have skill issues and the code is bad. Yeah, the trick question is the code is always bad. That's what I'm trying to say, is that the measurement of saying it's hard to change, I hate that, because it's not tangible. What is one person's hard is one person's easy.
If it does what it's meant to and it's easy to change, then it's good code. This is not about engineering as art, or over-engineering, or software developers being over-precious about the beauty in their code.
I would argue that if you change code that is super simple for you to change, either one, you have extreme domain knowledge, like me working on my tower defense. I just simply know where everything is. The 4,000, 5,000 lines of code in here, I can just simply navigate because I understand everything about the code base. Or B, you're working on a product so dang simple that even ChatGPT can get it right. Like, I don't see any other way. I think all code is hard to change when you have to change someone else's code because you have to adopt their mentality.
This is practical, pragmatic stuff. It works and it's easy to change. These things have a direct bottom line impact on the productivity as well as quality of the systems that we build. If you want to go quickly...
Bro was just drawing a line, really focusing on that line, like, whoa, I gotta go down again. We gotta go up. Right, dude, that was good. Man, the guy was cooking something magical here.
Activity as well as quality of the systems that we build. If you want to go quickly and build lots of features, you don't get to do that by cutting corners and writing bad code fast. You do it by working more carefully to create good code from the start. And so saving lots of unnecessary time and effort correcting the fallout that your bad code caused later on.
Oopsies.
For professional transfer to say,
hold on, I just accidentally skipped forward. I didn't mean to.
Carefully to time and effort correcting the fallout that your bad code caused later on.
I actually disagree with that statement in the sense that a lot of times whenever you're creating something new, you often don't know all the edges. And so to create quote-unquote good code is actually quite difficult. I think you'll spend much more time attempting to create something that's good, and then you'll later find out that you were completely wrong. And that's that. And then, what the hell happened? Did I get hacked by the Chinese government? I'm sorry, Edward Snowden. I got that China government on me. I forgot what I was saying due to the video thing dropping. So whatever we were talking about, I made a super good, valid, wise point. And now audio doesn't work. Okay, that's actually what I really wanted. Flip, you can keep this in. This is emotionally. That's just what I really wanted. I wanted not only a W take, I wanted to get defeated by audio directly afterwards. All right, hold on. I think I got this. All right, I found this really cool feature that if you go to it and you go and you say, do not allow audio, then allow audio, it seems to fix.
Believed that and defended that idea more strongly to misguided people pressuring us to cut corners, to deliver faster, because cutting corners simply doesn't work. The DORA data says that teams that produce higher quality code are significantly more efficient overall.
I do feel like this is one of the, I mean, I know Dora the Explorer is definitely, it's like, what is it, a Google creation, if I'm not mistaken? It's a nonsense metric. I just have such a strong feeling that all this thing is really saying is that people who are happy with their job produce code faster. Because they're like, oh, I like this. I like what I work on. What I work on is good. Oh, look at that. These people are producing more stuff. You know, I'm pretty sure it's like super subjective. And it's just really a measurement of you enjoying what you work on versus anything else. Yeah, I know. The problem is the quality improvement, right? To prove it. I know. It's confirmation. It's the most essential version of confirmation bias, which is whenever you find these things about positive metrics and all that, you really just find people who are like, usually a small team working on a precise product that's very easy for them to understand because they've all worked together and they're all happy with their job. And it's just like, yes, classic W's going on here when it actually is just simply people being happy. Confirmation bias was a whole class I had. Wait, you had a whole class to take back at Catholic Church. Oh my gosh. Why, Dad, why do I read what you have to say? Ugh.
44% more of their time on producing new features than teams that don't. 44%.
Maybe they're just working on new features. Maybe they haven't hit that one curve yet that really sucks. You know what I'm talking about? You know that one curve where it's just like, I'm doing everything that's so good. Oh, this is so fun. Oh, this is so lovely. Oh, shit, now it's 10 years old. I'm going to quit this job and go to a new startup.
More of their time on producing new features than teams that don't. 44%. That's a big win. Quality matters for commercial reasons because we go faster overall and we create better quality code. So as software professionals, we have...
Can we just rewind for a quick second? I know I shouldn't make fun of stock photos.
Win. Quality matters for commercial reasons because we go faster.
Dude, why was that guy typing with one hand? What was that? Who types with one hand? Is this CSI or whatever that one show is? Okay, The man is just left-hand typing like a champ. This is wild. We got a right-hand wrist watcher and left-hand typer. I don't even know what to do with this, okay?
Faster overall, and we create better quality code. So,
and if you look at the screen very carefully, I know, okay, we're breaking this. I know we're breaking this down.
For commercial reasons, because we go fast.
Look at that. Look at, nothing is actually changing on the screen at all. And there's like 3 boxes. This guy's like in PowerPoint.
Overall, and we create better quality code. So as software professionals, we have a professional duty of care to do a good job. This is not about self-indulgence or over-engineering. This is what we are paid to do, our professional duty.
What was that fake money? That didn't look like freedom units. I don't know what that money was, but it looked fake. My guess is it's probably Canadian due to the fact that it's fake. That's generally my general take on it. It's Canadian money. It looks like Canadian money. It feels like Canadian money. I'm just going to assume it's fake-ass Canadian money.
Duty of care to build software as efficiently as we can. To do that, we need to build high-quality software, not create crap quickly. Because if we optimize to build crap quickly, then the data says that we just end up building bad software more slowly. The worst of all.
I don't know. I would love to see, I really do hope we see some concrete examples, because I've been programming for about 20 years, and I have been in like the industry in some level, whether it's my own startup or professionally at a place or at a Fortune 500 company for at least about 15 plus years. And during all that time, I have really never seen good code. I've never looked at code and said, now this is good. It's always just like, man, I'm about to build something and I hate what was there. I'm going to simply hack my way through it because it already exists.
Of all possible outcomes. Let me pause there and say thank you to our sponsors.
Yeah, who's the sponsor?
We are extremely fortunate to be sponsored by Equal Experts, Transfic, and Semaphore. Equal Experts is a consultancy built on the idea of applying the techniques that we talk about here to build great software for their clients. Transfic is a financial technology startup applying advanced continuous delivery techniques to deliver low latency trade routing services to some of the biggest financial institutions in the world. And
that sounds like a fun job, by the way.
Are leading suppliers of cloud-based deployment pipeline technology support for your projects.
By the way, Transfic actually sounds like kind of a fun company right there. Right? Doing low latency pipelines. I would like that. I would actually really like that. I think that'd be a lot of fun. I think that'd be a lot of fun. This is actually one of my biggest pet peeves about big tech. You almost never work on something completely new. Then you have folks who don't know how to create original abstractions. They just patch things. Yeah, it's a very difficult place to be. That's why people typically you see this all the time, where people that work at, like, say, Facebook or at Netflix or at Microsoft or any of these places for a couple years, they come out and they're just not that great because they have never created something new. They're just they're really good at patching. They're just patch artists. And that's tough.
All of these companies offer products and services that are extremely well aligned with the topics that we discuss here every week. So if you're looking for excellence in continuous delivery and software engineering, please do click on their links in the description below to show them your support. So if bad code is so important, what is it and what do we do to avoid it? Here is ChatGPT's take on defining bad code. It's not perfect, but it's also not a bad summary either. So if bad code is hard...
I just assume ChatGPT is going to just literally ejaculate exactly whatever is on the internet the most. All right, let's see. Maintenance difficulties. Hard to read and understand. Bad code is often poorly structured, lacking clear comments, and not adhering to standard naming conventions. It makes it difficult for other developers or even original developer after some time to understand and modify the code. Poorly written code is more likely to contain bugs, which can be hard to track down and fix due to the convoluted, unclear logic. Have you ever worked on a really hard... have you ever worked on, I've worked on some bugs that are just, super duper hard, and it really wasn't bad code. It was just... I'm not sure if the difficulty of the bugs is necessarily correlated with the quality of software. I'd say it's probably more correlated with the difficulty of the problem. Performance. Inefficient code can slow down an application, leading to poor performance and scalability issues as the application grows. React mentioned. I'm wondering how long until I quit getting invited to React conferences and I'm no longer allowed to go to them. At what point am I no longer allowed to go to React conferences? I don't know when that time is, but it's coming. I can feel it. It's happening. Scalability, let's see. Resource management, bad code might not handle resources like memory and file handles efficiently, leading to potential leaks and crashes under high load. Is that bad code or is that just a bug? I just assume that's a bug. That's just like a bug. Like if you have a memory leak, that's just a bug, isn't it? Let's see. Security vulnerabilities. Poor coding practices can introduce security vulnerabilities, making the application more susceptible to attacks like squeal injection, cross-site scripting, and buffer overflows. Like I said, I wrote that one bug at Netflix that was categorically the worst bug ever that created its own class of bugs called the repulsive grizzly attacks that target both memory and CPU at the same time, and a single request can take down a single instance. We had security folks look at what I was building. We had multiple teams of people look at what I was building. Everyone gave a green check mark. It's not as simple as people think. Security vulnerabilities are very, very easy to goof, right? The repulsive grizzly exploit, yeah. I happened to also find that exploit and then reported it. But a lot of LGTMs, right? It's not security vulnerabilities. I don't think have anything to do with good or bad code. I think that's just an impossibly hard target altogether. Increased development time and cost. Longer development cycles, fixing issues, adding new features, and refactoring bad code takes more time and effort, leading to longer development cycles and increased costs. Higher debugging costs. Debugging bad code is often more challenging and time-consuming, requiring resources to ensure the application works correctly. I would like to say this, is that when you build any piece of software, you build it on a set base of assumptions. This is the way that world works. And then fundamentally, what happens is that a PM comes in and creates a new way in which the world works. Now, you're going to have to do some level of hacking to kind of make that happen. Then another feature is bolted on. That's a new way of looking. So you're going to have to do some sort of changing, which might actually cause some sort of downstream changing. And then a new feature is going to happen, which of course is going to require changes again here, which is going to potentially require changes here, which is going to potentially require changes all the way down here. And then it keeps happening over and over again, that your fundamental world was built for one reason, but the changes you are making or having to create are built on a world that you never were prepared for. And so when I see something along the lines of fixing issues or adding new features takes longer and longer development time, what I really hear is that you just simply have an older product. If you've ever worked on any product that's older than about 5 or 6 years, this is just such a true part of life. Every last projects. They're all built on some assumption at some point, and adding just requires this progressive downhill refactoring. And so when people say that, oh, these things don't scale anymore, we need to rebuild it, what they're really saying is we want to reset our assumption base, and then hopefully we can be good again for the next 4 to 5 years before things explode. Isn't this bad architecture or bad starting information? Well, no, because when you build, I typically think most developers build most things okay. Not great, okay. And I think it's best to try to build it okay. I don't think it's great to build it great, because when you try to build it really great that it can handle every single thing, you end up building your abstractions in such a way that just simply makes your time to complete fucked faster. So just building it to do the thing it's supposed to do often comes with a set of assumptions. You're only going to have this much data. You're only ever going to need to call out to this many type of data sources. You're only ever going to use, say, MySQL or Postgres. You're never going to, there's all these assumptions that are built in. And then all of a sudden someone's like, we need WebSockets. And all of your assumptions are fucked. And so now you have to go in here and try to wriggle your way in to adding WebSockets, because this wasn't what was it originally designed for. And so nothing ever actually scales, and it's a difficult process. And so when I see these things where people say adding new features is bad, I'm like, maybe it could also just be you're just using something that was built at one time, in which slowly and over time it now cannot meet those challenging. And that's it. Or meet those challenges. And that's it. There's nothing bad with that. Isn't that a problem mostly with monolithic infras? It's a problem about any sufficient sized piece of software. When I say sufficient, I mean something in the lines of 10K plus lines. Write anything that's 10,000 lines of code, and then add more features slowly over time. And you will find that no matter what you build, no matter how well you built it, things changed. Again, I built a autodoc for gaming at Netflix, and the autodoc was originally built on Kafka events, and then also some Mongo events. But as time changed, it went to protobufs and a completely different storage. And so all of my assumptions were built on this real-time thing that actually got completely taken over to be a post-like time kind of auto-docking, like a post-game auto-docking. And so for that to happen, all of my like assumptions had to get destroyed. And so that's like a very difficult piece of software to redo that, because now I have my entire entry into my application needing to be completely redone. Auto-docking, docking, D-O-C, like doctoring, right? So it would take a game, you'd give it an ID, and then it could go, okay, it was rendering at this rate, encoding pipeline got really slow, blah, 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 blah. It was able to do a bunch of the stuff, and so, when you have to change, I had to change my, shut up with docking. Shut up. When I had to change my assumptions, it caused a lot of things to change, right? Like every one of my objects had to change. Every one of my type definitions had to change. Every one of the things and it just caused a whole bunch of chaos. And just because assumptions at one point were not what the future was.
Hard to maintain, then clearly it isn't easy to change. If it has scalability issues, then it doesn't really work as it's meant to. And all of these other things also fall into my two categories of doing what it's meant to and then being easy to change, which I think are the simpler, more foundational and more useful ideas fundamentally. Good code needs to fulfill its purpose and be easy to change. Everything else is just a special case of those two things. It's possible that I'm being a little bit overly reductive here, but in this case, I don't really think so, because I can make my code scalable or write it to eliminate security vulnerabilities, and it still might be bad code if it's hard to maintain or offers a poor user experience.
I feel like this just misses the mark on all forms of maintenance. It's like you don't have time to add a feature and then refactor everything into today's world. You have to simply deal with the crap that's there, add the feature that you need to add, and hope that you don't have to like refactor too much. That's pretty much every single time I worked on any sort of C++ project was, God, I hope I don't have to touch logging. Please, I don't have to touch logging. Oh, please, I don't have to touch this system. Please, if anything, I don't want to do this. It's just like, if I can do all my changes without touching those, I know I'm going to be good. But the moment I know I had to make a change there, I know it's going to be really difficult.
So if we fix all of these things, is the code good now? Well, maybe not. To achieve good code, our code needs to fix all of these things, and depending on context, probably several more not listed here. If uptime matters a lot to my business, resilience may be a much more important defining characteristic of my system's quality than, say, scalability. So code that isn't resilient is bad too, but that isn't covered in this list. In this case,
that's also that one can also be language difficulty. JavaScript, I think JavaScript is difficult to scale comparatively than Go, or errors. Any language that's errors as values versus thrown errors. I think that thrown errors are just more difficult to deal with for resiliency. I've seen very resilient code, but it's more difficult to scale thrown error code than errors as value code.
A detailed list is less helpful really than a generic statement of principle, because we may always miss something off the list. So although bad code is often defined with lists like these aren't really definitions, but rather only reminders of some of the things that we probably need to get right depending on our context. But using the more fundamental definition of code as something that fulfills its purpose.
Yeah, I mean, hiding errors. This one just literally hides an error. This one logs out the error. I mean, I do agree that logging out your error is better than not telling anybody. I don't think anyone's disagreeing with that. Silent fails. Yeah, I mean, silent fails is that bad code, or is that just a rookie issue? For me, that's just rookie issues. Don't use using global variables. Hey, I'm not going to lie to you. Sometimes I use global variables. You know what? We're doing it. Guess what? It's a global variable right here. Yeah. Throughout my entire code, I stringify everything inside of my Zig program through a single global buffer. Is that bad or good? As it should be. Global variables isn't inherently bad. I agree. I don't think global variables are inherently bad. I think that they're just easier to do incorrect. Unfollowing right now. Damn globalists. Damn globalists. It's literally, the worst part about it, it's literally a global list. Damn, it's a global list. This is badass. I thought it was badass too. If you look at the code, what it does, it literally it creates a 2 to the 16 sized buffer, and then you just grab slices of the buffer out, and then when you want to stringify something inside, say, Zig, which is kind of, generally speaking, more hard to stringify, I just grab 250 of those bytes and stringify it right into that, and then I know for a fact that can only be used for a moment. And once I go through a couple cycles, I'm going to rewrite over myself. So I just simply don't hold on to it. It's a scratch buffer meant to be used in a synchronous fashion. It's great, right? A better way to say it is keep all your variables to the smallest scope you can. Correct. Pre-factoring kills your project. I actually agree with that. I fully agree with that. To me, this is more of a skill issue. This is just like this right here. Bad versus good here is just purely experience. I don't think it's bad. I think you're just inexperienced. You just don't understand why it's good. Because no one would hide an error unless if they had a really good reason, or B, they really just didn't know. And that's it. It's just skill issue. That's it. Back in my days, we called that prototyping. Yeah, it's prototyping.
And is easy to change is always true. So I think he's a much more useful tool to help guide our choices.
That last one was, let's see.
So I think he's a much more...
Use cutting edge libraries. Sometimes, cutting edge is not always good in all cases. It's just a real life,
More useful tool to help guide our choices. But let's dig in a little bit deeper than that.
Long function names are better than short ones. Maybe, sometimes. Right? If you had a function called sum and it takes an array of ints, isn't that, do you need a longer name? I think naming the name, the name should be what is most clear in the minimal fashion. I'd go with the inverse, which is you should have the name that provides the clearest indication into what it does in the shortest amount of characters. You should actually try to inverse it and make it as short as possible, but as clear as possible. The name is the name engine.
Most lists of things that describe code as bad look something like this, and often they start with readability. The problem
is technical debt bad, or is it just reality? Is slowness of a program bad? Or is that because you weren't prepared for a million lines? When I did the gaming stuff, I was not prepared for 10 million objects being created. I just built a system that wasn't meant to be fast in that kind of way. So was it bad? No, I don't think so. I actually don't think it was bad at all. It just was life. It just was the world that I came into. So was it not scalable? No. I just didn't optimize for a case I didn't think existed. By the way, Lithium, you son of a bitch. Thank you.
With this is that it's my impression that what we mean when we say readability matters when comparing good code and bad is often, rather ironically, lost in translation. Okay,
I'm going to do one more. So, since I'm on the tower defense thing, and this is the thing I've been building for a little bit, in my game state, this is going to be very offensive. It's very offensive. But if you look for the term alive, what you'll notice is that I use this term alive a lot throughout my code. And you're probably thinking, well, what is all this alive stuff being, right? Like, what is all that? Well, it turns out that I literally have a tower list that grows ad infinitum. I have a creep list that grows ad infinitum. I do not try to be smart. I just keep on allocating one new one. The thing is that I know that there's not going to be more than a couple hundred towers, maybe at max. Maybe the amount of creeps could potentially get up to 500 at max. So it's like, do I really want to create a free list and making sure and all that? I don't even prune. I just simply, if it's not alive, I don't update it. Right? Is that terrible? No, it was from Casey Moratori, which he's a great game engine creator. He said, hey, when you're doing something and it's small and you know it's not going to be that big, don't be smart. Be a savage. Create it intentionally simple because it's super easy to maintain. Static allocate 1K each. I didn't even do that. I just simply, I could do that. That would also be a really good way to do it, Demon, is actually just have a allocation list and a next up. That would be even easier. And then assert if I cross that line. And then I go, oh, wow, look at this. I've created an environment in which my 1,000 creeps now breaks the world. I'm now going to change this so it's something bigger. Or maybe I now need to change the data structure. And so it's kind of interesting that you could... that I'm literally doing something in which people would say bad. I don't know if it's bad. I'll be honest, you learned this after programming Go, but real talk, I learned it after talking to Casey Moratori. Because you know what, for me, that would be considered bad programming. I would never do that. But Casey just kind of pulled me back and said, hey, this is a time where you choose simple over correct. It's fine. You will be able to move faster and build your game. Down the road, you can solve that if you need to. It's easy to make that efficient. That's a known problem. You already know how to solve that problem. I'm like, I do. It's called a ring buffer. And he's like, exactly. It's just a pool. I'm like, yeah, okay, this is good. It's easy to fix. It's not hard to fix. And so it's like, okay, then why make it hard?
Quite like this from the C2 wiki. And one of the most amusing things about it are the comments. There's a link in the description to those if you want to check them out. The comments argue quite a bit about the ins and outs of these 5 lines of code and the coding practice exhibited by them, which goes to show that good and bad are somewhat subjective ideas when we get too lost in the detail. Though code that fulfills its purpose and code that's easy to change are a lot less subjective, closer to real measures of practical outcomes that really matter to us.
I feel like he just validated me and then went back on it. Also, something that hasn't been mentioned here is easy to change. It's proportional with familiarity and experience. And so a new engineer would take significantly longer than an engineer who's worked on the product. So again, I'm emotionally bruised right now. Can code be bad and good at the same time, depending on the engineer looking at it? That just hurts me.
But back to my current point. Fundamentally,
Schrodinger's code, people! Oh my gosh! Sorry for pausing. Sorry.
Readability doesn't mean that you, the author, can read it. Of course you can. In the moment that you wrote it, you must be able to read it, otherwise you couldn't have written it. But that is nowhere close to good enough. Not a hard...
Did we just get hit with a Kamala Harris? Hold on. I'm coming back. Have we been unburdened by what has been? Quantum code, it exists both in good and bad at the same time. I don't know what we just... You can only write code in which you have written. For if you have written code in which you do not understand, then you haven't written the code. It's like, I've been unburdened by what has been, and I agree.
High enough bar to strive for. Readability means considerably more than that. I think that the best code is readable by almost anyone who understands the problem being solved, technical or not. If you're writing medical software, a non-programming doctor would understand the core logic of your system with some...
Disagree with that completely. I actually was agreeing partly with that take because I actually think he really did do a good job saying he finally defined it better, which is an engineer who's very familiar with the problem should be able to make changes. I actually agree with that. But then saying not technical, that's crazy. Right? Oh yeah, hey, don't worry. That's called an abstract constructor. Okay, see, you can't create an abstract object, but you can inherit from the... So when you inherit, it doesn't mean that two objects made one baby. It means that it's like mitosis. It's like they go from one to another. You know what I mean? It's like, what the fuck? What does that even mean? Dude, explaining programming concepts to non-technical people is insanity. It's actually nuts.
Some help. If you're writing a game player should be able to follow the logic of your reasoning, again, probably with some help.
So when I update a projectile, I assert to ensure that the function, these virtual functions I've created do create. If it's not alive, it returns. I grab the target by switching on the target type and grabbing it out. If it's not alive, I kill it. That seems kind of odd. If the bullet is not alive, I kill the bullet. Wait, if the target's not alive, I kill the bullet. I assert some stuff. I have a bunch of math equations go on, and then I do this little nice thing, which is position add 2 norm scale delta p, negative delta p times speed. It's that simple. Do you know do you know about vectors? If you don't know about vectors, I mean, come on. Everybody knows about a little bit about that T-norm scale, baby. Kill self, sus. Dude, if you ain't killing yourself, what are you doing? Okay. Will you share the code on Zig Tower Defense? It's open. It's already out there.
I think that this is a good sanity check to think of the least technical person who understands the problem being able to read and understand the intent of the code. Dude,
imagine doing behavior trees and then trying to explain to somebody who deeply understands how, like, a player, how an NPC interacts with the environment, trying to explain to them how the behavior tree works. Like that's crazy. It is impossible. Like, I think I understand, like, to be charitable, what he's trying to say is that the code should be, if you are a subject expert, or if you're a subject matter expert, and charitably to say you can read the code, you should be able to read anyone's code that's written stuff on this topic. Fair. But to say that they're not technical, this is very, I'm really struggling here. I'm really struggling believing that at all, especially when it comes to trees or recursion. Like, recursion, as a technical person, took me like a month to really get, like, I struggled. Oh.
I don't always achieve that in my own code, but I think that I usually write code that I could at least easily explain to them. Here's an example from one of my pet projects. This is a technical code, but within these constraints, I think it's readable. So
it looks like it's taking HTTP and creating some sort of method on it, in which then something else will be called to produce out HTML or a change. Right, like, to me, like, if I'm being completely fair, I don't really understand what param decoders is, but now imagine like, I know what classes are. I know what implements is. I know what private final is. I know what public, same name as the class is. This is Java. I know the Java. Hey guys, this is Java. Imagine trying to explain this to someone who's not technical. Class is already difficult, let alone implements. Right? It's an interface. See, an interface actually operates on it's really just like, so if you think about it, an interface is just a vtable which contains an opaque pointer and a list of functions, and then you use the opaque pointer as the first argument into the function. What?
So let's try that out. This is a small part of some infrastructure that is meant to take a Java class and use it to generate remote calls and remote proxies to handle those remote calls, translating them into calls into a service. This code is on the receiver end of one of those remote method calls, and so represents the translation from a remote call of some kind into a local call to the code that actually does the work. None of this.
Flip, could you add in, during this explanation, you know the sweating guy that's typing really hard, the FPS tryhard? Can you just, like, overlay him on it as it happens? Because this feels like the right meme to have, where it's just like, he's getting in there, he's sweating. Dude, this is it. This is the moment. Unpopular take. If you can't dumb down a technical procedure, you don't understand it fully. All right, dumb down behavior trees, right? I think it just depends on the technical depth of the thing, right? Like, dumb it down. You know what? Have you ever got around a group of people that aren't technical and then they ask you technical questions such as, how does Bitcoin work? Have you ever attempted to explain to anybody how Bitcoin works? How about monads? You want to try out monads for size? Okay, so monads are like a burrito. You know what I'm talking about? Like, you don't care about the insides. It's about the wrapper. It's like the tortilla. It's the tortilla to the burrito. Now, sometimes you like a wheat tortilla, but sometimes when you get a wheat tortilla, you also want to put on a little bit of flour and maybe some beans on it. But then you lift out the insides of the burrito when you want to eat it. You know what I'm talking about? You, like, put your hands in the burrito and you get the insides out. That's called a lift operation, or catamorphic if you want to be functionally correct. Just lift the insides out with the catamorphic scoop, bro.
This matters very much, except as scene setting context, so that you can understand the goals of this code. The class is a runtime translator, And here we are registering the service that has the method that does the work and creating a translator for one specific method call within that service identified by the method parameter to this constructor. I know that I'm largely just repeating what the code already says, but that is kind of the point.
But that's the thing, is that what he just said records so much pre-baked in knowledge. I would have to understand the problem more fully to even understand the purpose. Why? What is this method? Is the method is the method a function, or is it some sort of string? Is it some sort of is a method an interface? Like how does this happen? I'm struggling understanding what's happening. What is it producing? Why are these params? Why are you creating a wrapper to it? What is the point of a service? Because if you already have the method and the method params and how to decode those parameters, what's a service? I'm genuinely, real talk, I'm actually struggling trying to understand that because I don't understand the words. And so even though you've said all the words, it doesn't mean I actually get it. And so again, explaining a technical concept to a technical person often can mean you don't understand it. And that was me attempting to try to understand. I'm really trying to attempt to understand this, which is I can see why you'd have a method and params. I fail to see why you would ever have an object that's really just a function call, let alone a class. Like, barring all the things I don't understand that by itself. Why a service extends a method, I don't know.
I think that this is all that you need to know to put this code into context. But let's look at the next layer down. And note, this code is internally layered and named so that each...
Hold on, we actually have someone trying to explain a behavior tree. Would a behavior tree basically be if this, then that, similar to a conditional statement but with more actions and functions? No, it totally depends. It's a behavior tree. Obviously, each node defines either a behavior that the thing should take or a translation of what next node to go to based on the current state of the world. And so some of those nodes are state-bound, sequence. Some of them aren't state-bound, selectors. It's a form of a state machine in which uses sequences and selectors to get down to the behavior that should be operated on. States' rights. It's a federalist system. Global switch mention. Yeah, it's effectively a switch statement. Yeah, they're really, really great. They're very, very fun to make.
Part is focused on only one part of the job. We have a layer of abstraction within this class, public methods that orchestrate the work, private methods that then do the work. So now what we want is to create a collection of parameter decoders. Here's the code for that. And sure, there's some technical boilerplate imposed by Java here for creating fixed size arrays and so on, which we may have to explain to our non-technical reader. But for a moment, try and separate the meaning of the intent of this code from the plumbing of how Java works.
Imagine trying to explain what decoding is. Like, even separating out the fact that this is a list of decoders operating over parameters, just the idea of decoding is just so difficult. Dude, I barely do it. It took me 4 years of college to really get to the point of understanding decoding.
The core of what is happening here, the plumbing aside, is, I hope, pretty clear, even to our non-technical reader. We're creating a new parameter decoder for each parameter and saving it for later use. Here's the code that uses it later. When a method is invoked, this code is called, and it iterates over its predefined list of parameter decoders that we stored earlier and uses them to decode each parameter in turn. And then it makes the method call with those decoded parameters. There are several things that I think help this code to be readable.
Is this just to make an HTTP call to something? I think readability is in the eye of the beholder. I think that, Code Girl, well said, wherever that went. I feel like I've said that exact same thing quite a few times. It's an RPC call of some sort. This feels like readability is in the eye of the beholder. How many people here work in Java? Type 1 in the chat if you work in Java. Okay, we got some ones. Out of the people that work in Java, how many of you do a lot more kind of clean codey kind of abstraction style take like this is? Type 69 in the chat if you have to do more clean code / that stuff. Okay, Jeremy, we got a couple of 69s. Okay, out of the 69ers, how many of you guys feel like this this is pretty straightforward type code, in a sense that you're not actually struggling with following along. We got a couple ones in the chat. I think what this means is that readability really is in the eye of the beholder. I think walking through this, like what I think about is debuggability. My ability to debug something obviously is based on the familiarity with the code and the complicated nature of the bug. But if I had to walk through all this just to get to the point of calling a service with the parameters, I feel like this would be really hard. So for me, it's more about how many times do I have to switch context to understand what's happening? So when we finally get down to invoke, what I have to do is I have to understand how the parameters decode what's happening, then to pass that back in, and then how the method invokes on the service. Like there's quite a bit of abstraction that I have to understand, because then it's like, oh, wow, I don't really understand why we're decoding parameters that way. For me to understand why we're decoding parameters that way, I then have to back up and understand how we initialize the parameters. Then I have to figure out how were those parameters passed in to be initialized inside of this. So I have to like walk quite a bit of distance to figure out where or who is calling what. And then if this thing is called by a bunch of different methods, I then need to figure out and how to debug on the outside to figure out who is actually calling and setting up this service caller. And for me, that's like a bunch of steps. And for me, that's very, very difficult to build or to understand it, because now I have to understand a lot of the world just to understand a single call. That's a lot of hops to understand why X parameters goes into Y method. The documentation, I'm less concerned about documentation. I typically find it's much easier to understand what the code does by walking through a debugger. Like when I really want to understand complex code, I use a debugger. It just feels easier to me. It just always will feel easier to me.
Readable. Each part of the code is small and focused on a simple part of the task. I've chosen names that I aim to be descriptive in terms of the problem and their role in solving it. Given the context of the problem, I'm aiming for names that are meaningful and practically, given an understanding of the context, clear enough that their role in solving the problem is clear.
It's true. I would say that generally speaking, the names, except for the React service method, obviously I don't know, is that React library? Is that something else? Blah, blah, blah. Who really cares about that part? But the rest, yeah, I'd say good names. Good namings. He did a good job on the naming. Except for this right here. Can we all agree this catch exception, throw new exception? I'm emotionally hurt by just exception wrapping. Okay? This exception wrapping is just emotionally bruising me. The catch and throw. Ugh.
Clear to most people, including me in the future. And in that last respect, this code was indeed readable, because I wrote this some years ago and still understood it well enough now to try and explain it to you. I think that this counts as readable code. Second in this list of common problems, though, with bad code is complexity. Striving for readability in the sense of easy understandability helps us to manage complexity, certainly. But even more so, working to prefer testable code helps with that.
I will say, I do want to throw it out there that for me, readability honestly matters less than I understand how state moves. For me, that's where most of the complication comes in, is trying to picture in my head the state and how it changes over time. Because that code obviously had state coming in that would then call into a list of decoders that would produce a new state. And so like trying to understand that state transition would be very difficult, and that would take me more time to try to understand. Like for me, that's where I'd spend all my time. Deep state mentioned.
That too. By adopting test-driven development, it's difficult to avoid preferring testable code in our designs. It promotes greater modularity, cohesion, separation of concerns, abstraction, and sensibly managed coupling. It's hard to write testable code that doesn't demonstrate those features. Let's look again at my very simple real-world code. As I said, this is part of a real-world personal project. It's not written as a demo for this video, that's why I chose it. I developed it from scratch with test-driven development, and it works and does what it's meant to do. But it's also very easy to change because it is modular. It's a collection of several small pieces, each one dedicated to a small single part of the overall task. So it's also cohesive and has good separation of concerns.
One thing that's difficult, though, as he talks about, so this is the Theo argument, which I think Theo is correct on this argument, that level of testing where you're testing all these different little separation of concerns, all these different little parts, it gets really hard to refactor. Because when you refactor it, you literally invalidate a whole series of tests because now you have a new pipeline. And I do find that that type of over-testing can be really frustrating. And I never know the correct level to do it. And I'm still trying to figure that out in game programming, how to do it right. I have some other ideas that I want to do, but I don't know if I'm correct on it yet. You know what I mean? I'm still working on that thing. Deleting tests is part of the process. I know, but if you delete the test, then you ruin the entire idea of code being able to refactor with confidence, right? If you can refactor with confidence, that means you have a set of tests that didn't go away when you changed a couple methods. It means you don't have confidence anymore. And so there's definitely something in there. TDD is, in my opinion, a way to premature optimize. Interesting. Maybe. As long as those are your personal projects and not group projects, you'll never be right about refactoring. Get different levels of other folks involved is the measure. Yeah, perhaps. It's just, you're definitely right at some level, but just the entire idea that TDD is the answer to making something that reduces its complexity. Sometimes you add complexity by making something debuggable, or not debuggable, by making it testable. By making it testable in the sense of being able to do isolated individual tests to it, you necessarily have to add in an abstraction in which you can mock. This does happen. And when you can mock something, it can immediately make things more difficult. Because now you have a layer in which it jumps.
Because each part does one thing and everything needed to achieve that one thing is within the small, relatively simple piece of code. Each piece of code interacts with others through abstractions that hide information. The constructor delegates the most complicated part of the initialization to...
All right, someone's asking what mocking is. Just so everybody's on the same page, it's really, really simple. Let's just say you have a function called foo, and it needs to go out and say, makes a request to a service and return data. So you could have something that looks like this, a URL, and then it returns out some sort of object, right? Well, what's the problem here? Well, obviously, I'm going to have to go out here and I'm going to have to curl out this URL. Well, I've just bound the implementation of my function to a very specific way to get data. Maybe we don't want to do that. Maybe we want to be able to read it from a file, or maybe we want to do something else. So instead of a URL, perhaps you have something like a data provider, right? Some sort of provider. You see this term all the time, provider. I think I've even used this term, right? And then this returns out an object. And then you're like, okay, now I can do a provider. Now this means that when I'm testing, long as I adhere to the same interface, I can pass in a fake provider that returns the object you want versus doing the direct action that you meant it to take. And so a mock can literally mock out part of the service. Now, the danger to mocks, obviously, is if I was doing a curl, what are the potential errors? 400s? 500s? What about a 300? What happened if you get a 300? What happened if you get a 302? What happened if you get a 303? Do you know the difference between a 302 versus a 303? You may not even know the difference. Yeah, what happened if you get hit with 418 on a teapot? It's a 1. The difference is 1. Oh, that is unit testing at that point, because you have to test the type of errors that are coming back from the provider. In fact, that is very, very much so unit testing, is that you're testing a single unit in which your abstraction has potential error conditionings. You're testing a literal if statement within your code. Code Shutter is saying nope. Why is it not? So let me get this straight. You have a function in which has something that's passed in which you are going to call that thing out, const x equals await this thing out, do an operation on it. Oh, but now you realize, crap, I now need to handle the types of errors that are coming out of this. So your foo function gets a little bit more intense. It now does a couple different error conditions. Is it a 302? Is it this? Does it need the redirect? And you have some sort of abstract object now. Now you're like, I need an abstract object like re-request, or maybe new location, or maybe new object to go create. If your statements to test are abstractions wrapping curl, the same way you wrap your mock. Again, this is the whole problem that I'm saying, is that this could be an entire enormous set of different errors, right? What happens if it's a retriable error and you have providers that are retriable? You have to test that if foo is retriable. That is a unit test. You have to make a provider that mocks out the ability to do retrying X amount of times and then does it. Like that could easily be 6, 7, 8 lines of code inside of foo, and maybe it's 100 lines of code inside your mock. And that's the biggest problem is mocks suck. Mocks don't represent reality. 302s are for redirects, correct, and 303s are for redirects, but you do not forward on the HTTP verb. So a 302, if you do a delete call, you have to forward on the delete to the next URL, whereas a 303, you actually forward on a GET request. For those that don't know, it can be a little bit tricksy, right? A little tricksy there. All right, hold on one second. There we go. 307, you have to preserve verb and data. Oh, I did not know that. A 307 is preserve verb and data. See, all these different things. There's a lot. There's quite a bit in all these things, right? How do you test the same scenario if not with mocks? That's the hard part. Generally speaking, whenever I do something that requires a mock, what I do is I try to do the object translation as a function. This is like my logic that, takes A and produces B. It operates over a function. And then I have a separate function that's usually on the outside that's like get A. That way, I can test the thing that I find to be very complicated, and I don't test the thing I don't find to be very complicated. I'm not going to write a mock. I typically do not like mocks. I typically think that when you're doing mocks, no bueno. No bueno.
To a private method that's clearly named for what it is that it achieves in the context of the constructor. That allows me to keep the intent of the constructor clear to any reader. These abstractions hide information depending on the fewest simplest parameters to get the job done. So even internally, it's also minimally coupled to achieve its job. And each part of the code, even at the level of methods within a class, is abstracted from every other, so that I can change any single method with minimal or zero impact on the others. There is more to even these few lines though. This code is clearly object-oriented in terms of design. A React service method is an object and it contains a collection of instances of parameter decoders which are abstract and polymorphic and aimed at decoding specific types of method parameters. There is a state and behavior here, so it's definitely object-oriented. But look a little closer. This code also has no side effects. All of the state in these things is created during its initialization and is declared final, which in Java means that it won't change once it has been initialized.
By the way, that is nice. I'm curious what final means in the sense that, does it mean the pointer to the object won't change? Or does it mean that the internals to the object won't change? I'm pretty sure it means that the pointer to the objects will not change. Yeah, it's pointer only, right? It's reference only. Just to make sure I understand final correctly. It's just the final object, not the final thing. Side effects, it does not create side effects. Well, it can have internal mutability, right? So if you call a service and that service is invoked, you could actually have a state change on that service that renders it into a new state the next time. So mutability is difficult. Mutability equals business. Mutability is your business value. This is just a constant pointer. But I mean, he is correct though. Having some sort of immutability on OO design does make this a little bit easier to reason about in the sense that you now just have this one item in which you're creating, and that's that. Okay, that's fair. That does make it nice. Mutability. Okay, calm down.
So the state never changes for a given instance. This too limits unexpected changes in behavior later. And even though it's a functional idea, perhaps, here I'm using it in an OO system. So this code is behaviorally simpler and so more deterministic as a result. I'm not using this code to boast about my design or as an example of perfection. I'm sure that there are ways that it could be better. I'm always sure that there are ways that my code could be better. I don't know if you will agree with me.
The problem I have generally with OO, especially OO like this, is I don't really see it doing anything. Right? Like it's a very complicated way to not do a lot of things. I feel like this could be done also in just very little bit of code. And it just feels like there's a lot of abstraction and having to jump around just to make not that much happen. I mean, this is literally a data stream that you need to parse out a data stream and call it on a service, you know? And so I understand this is readable, but for me, this is just really hard to debug. If there's a bug somewhere in here, there's just a lot of abstraction that you're going to have to comb through to find out where exactly does the bug exist. That's why I've never liked this approach. That's why I've always generally stayed away from wrapping abstractions with abstractions, because it just becomes a nightmare. And then when your underlying abstractions change, you have this like whole chain event that explodiates.
Or not, that it's readable and less complex. But even if you don't, given that it is well unit tested as a result of being built with TDD from the start, I hope that you will agree that this code is certainly easy to change. For example, I can trivially add support for new parameter types if I want to without changing any of the code that I've shown you so far. And because of the separation of concerns in my design, you have no idea how the transport of the data representing a method call works, or how messages are routed between caller and receiver. These are indeed separate concerns and so don't impact on this part of the code at all. I chose...
But how many different ways are you doing something? Right? Like how many different ways do you need to do something? I'm always so confused. I'm always very difficult. I always have such a like... I often run into these things where there's like tons of abstraction, and then when you really get to brass tacks, it's just like one way to do it. You built it all for the flexibility of an event that never happens, and when it does happen, you have to rewrite it anyways. But you built it all just so you can unit test specific things, and it's just like, is this really where the W is happening? Maybe if you took all of this away, and you get a stream of data, and you just simply decode the parameters, which, by the way, you have to read the entire stream when you do when you decode the parameters. Just having stream to parameters as a singular function, that's really easy to test, because you craft the stream you want, you show the output. Craft the stream you want, show the output. There you go. Bada bing, bada boom. I have 3 unit tests that cover these kind of corners. Go for it. Live on and prosper. And then you just, it just feels like it's easier. I'm a one implementation. I'm a very much so avoid abstracting almost exclusively kind of person. Speculative architecture, very dangerous. It is very, very dangerous. I have something similar I did 7 years ago that was written in C++. If you'd like to check it out, I don't want to. My very first time building a game was way back in like 2007 or 6 or something like that, and I did it in C#, XNA, and I had like 7, 8, 9 layers of inheritance. And that's kind of where I learned that I get emotionally bruised. And then I just didn't want to do that anymore.
There's this code because it's real world, not some
XNA
artificial example. This is what my code tends to look like when I write it. I also chose it because I think it demonstrates what I mean about using the tools of modern software engineering to guide me towards what I think are better results. By working iteratively in small steps and using tests via test-driven development as small focused experiments in design, this is the sort of code that I tend to end up with. If you'd like to learn more about that and how to do it, do check out my book. Each part here is consciously designed to be as simple as I can make it.
I think I think this really just expresses that some people learn to think in a specific way and they like to think that way. That's it. I don't see how you can't produce the same ending result of software his way or somebody else's way. I think you just have to simply drink the Kool-Aid and do it specifically one way, and you do it long enough, you'll be good at it. I like my tribe. Join my tribe. Yeah, I think this is just a tribe. It's just tribalism. That's it. I'm not convinced that OOP isn't a successful way to create things. It's just not the way I like to create things. But maybe if I understood the abstractions and I did it for years, maybe it'd become really simple. Maybe then it becomes the engineering side of things.
Each part, even each function, method or variable is focused on doing one thing. And so I think that all of these things help to make this code easier to understand, more readable,
by the way, I do doubt,
more likely to achieve my goals for the code, whatever they may be. They also make the code much easier to change when I've got something wrong or the circumstances of the use of my code change and require me to change it to match them. Thank you very much for watching. And if you're not already a Patreon supporter, please do consider joining and supporting our channel and our production of this content. And thank you to all of our existing Patreon supporters so far. There are lots of benefits to joining as a Patreon member and lots of additional information that you can gain from there. Thank you and bye-bye.
Whew, got to turn that down just slightly. Really just get slapped in the face. All right. Well, all right. Good luck with that one, Flip. Flip, I hope you enjoy this hour and 20-minute video just for you. Now that, my friends, is a wrap. Yeah, I think I always just have a really difficult time with OOP. I know people are saying there's people in here that are just like, I love OOP, but every time I've done enterprise level code, I've always just disliked it because there's just so much type. It's like a form of type masturbation, but it's like pattern masturbation just to do the thing. And then it often just comes down to you built all of this apparatus just to produce one config for one service. And it's just like, why? Why all of this, all of this? Right? Why? Why all of this when it was just nothing this entire time? I feel bamboozled. I feel absolutely bamboozled by my config factory when at the end of the day, it's the same thing. All of this for 10 users for my startup and all of it for 10 users for my startup. Hey, don't worry. I mean, we've done it wrong in multiple directions, right? Like one thing that you can see a lot is that there's this joke that runs around that says, I have more microservices than users. And that's not necessarily a joke, as this does actually happen, right? OOP often leads to over-engineering. I think it's because you can see why a problem can be solved away. I think OOP has this really interesting aspect to it where you have all these patterns. And you can easily go, oh, I can see how this pattern could work to solve this problem. And then as you start doing it, you're like, okay, well, now that I'm doing it, I realize that this part could be solved with this pattern. And then you start doing it, and then, oh, but I'm a test-driven development, so at the end of all my leaf nodes, I then need to use strategy pattern such that I can make sure I can test each one of these little leaf nodes in my kind of architecture. And so it's just like you keep abstracting all the way through. And so it hurts. OOP would work if people had self-control. I don't have self-control. I know myself better to not have self-control. Meanwhile, procedural is do-it-yourself masturbation. Also fair. Procedural could be shit code too. You're absolutely right. I think what we're all saying is your code is horseshit and it doesn't really matter. Your beautiful code that you think is good and well-engineered is absolute horseshit to somebody else. That is it. That's the only way around it. I'm sorry, that is not black pill. That is not a doomer. That is just reality. I hate to say it. I hate to be the one that kind of breaks your bubble. Like a real talk, I think that this is great code right here. This is the entry point to my engine. I think this is a great game loop. Honestly, I think this game loop is stellar. I think this game loop is amazing. I think I've seen a lot of game loops, and this game loop is the best one I've ever seen. I know plenty of them, and they keep telling me that I've written some of the best game loops ever. And some people would say this is horseshit code, and that's fine. But for me, it's beautiful, okay? This game loop fucks. I know that's what I'm saying. This is a beautiful one. Okay, we got like deltas, we have a multiplier effect, we have input, we have active creeps and determining what to do, and validating state and rendering all in one giant loop. It's amazing. And yet, do you think this is gonna go? Do you think anyone that's like, you think anyone's gonna be happy about this? This piece of code, this game loop that spans what? 40 lines of code, 35 lines of code with another how much setup code? That ain't gonna happen. Whoa. Are you trying to insult horseshit? Okay, calm down. But again, this is what I consider pretty. I think this is beautiful. I think this is wonderful. On that thing. So, who's right? I don't know. Is there ever right or wrong? I feel like the older I get, the more I realize that I just want to build something. That's it. The name is the Premgen.